Okay, anyway, it somehow stopped working. I will fix that later. But at least I get some voice recorded so that we can stay to this class. Alright, so during last lecture, do you remember what we talked in the last lecture? Nothing, right? Yeah. Right. We talked about the syllabus and our plan and our schedule and some of the suggestions. So today we will actually start our lectures. So this course is actually a pretty easy one. So I hope you can have maybe a relaxed time during this course. So compare. Have any of you taken the formal method? Yeah, I think you took that with me, and none of you take that course. Okay. So yeah, this course is nothing comparable with that one. Yeah, that one is pretty cool. How do you feel? Yeah. Yeah. Okay, so if you're planning to take that one, the formal method, probably you will take that with me because I guess right now I'm the only one here who can offer that course. So yeah,
I think
but
they're getting rid of it.
huh?
I think they said they're getting rid of it.
No. They will offer it maybe once every 2 years or something like that. Because there are not a lot of us can offer that course. Okay, but this is just a lot of definitions and discussions, talking, concepts, those style. Okay, so we're talking about object-oriented. So the concept of it. Yep. Let's talk about it. Object-oriented concepts. So more or less, you've already have some pre-experiences in any sort of programming, right? So you can name a lot of programming languages. So let's see, C++. What else? Right, Java, Python, and
C#.
C#. Okay, what else? All object-oriented? No object-oriented. So other than the object-oriented, what else?
Object-C.
Object-C. See, I said not object-oriented.
Like
Yeah.
COBOL or something? Or Pascal?
Yeah, Pascal. And you forgot C, right? You mentioned Objective-C, C++, right? C#, but you forgot C. C is basically my first programming language. So that's not object-oriented. So when we're talking about object-oriented, okay. So what is the other side of it? Yeah, procedure. So let's not talk about the concept yet. So I believe you more or less have some experience with C, right? You know what that is. Okay. So based on your experience comparing the C and maybe Java or C#, whatever, what do you think is the main difference there? C and C#.
C is function based, and Java.
Yeah, sure. That's one of the function based, the object oriented. More detail. Yes.
Control over the way that you handle memory,
Control
over memory.
of the memory. Yeah, that's down to the implementation level. Yeah, there will be some difference and some lot of things in common in the down if you go down to the detail. But think about higher level.
Isn't it harder to do encapsulation with C?
Right. Yeah, encapsulation is actually one of the important feature of object-oriented. So, so what is the encapsulation? You talk about encapsulation. What do you think is the
Just being able to
encapsulation?
hide like information, so in C you can pretty much access anything and create a mess for yourself.
Yeah, most of the time it's hide information hide. Okay, and it's actually another concept is in encapsulation it has a group the data and its operations. So let's talk about them in a more formal way. The object oriented. Okay, so this I believe you talk about this a lot. What is an object? So I just go through it again real quick. An object is a software entity. Here in this course, okay, an object is a software entity that mirrors the real world in some way. Okay, so a software object in object-oriented programming has data. One thing is data, and the code that respond to the instructions, the code that do something to the data. And think of the code and the data that being welded together. The code completely wrapping the data in a shell to protect it from hostile outside world. Okay, so the pure OOP. Actually, if you think about Java, you can have a data maybe public, okay, protected, private, right? So as long as that's public, I know people like to do that a lot, to put everything as public, so that you can easily access every data with another object, right? But that's not it's supposed to be. Okay, it is supposed to be this way. It's totally hidden, protected from outside the object. If you want to access data, you have to do it through the operation, those method. That's some sort of pure salts of the OOP. However, yeah, a lot of language we can do some public thing. Yeah, but that's sort of evolve or improvement over this idea. But the most original idea is hide. Information is hide. Okay, so a whole bunch of definitions here. And here another definition, an object has state, behavior, and identity. Okay, so object has state. What is the state of that object?
Is it data attributes?
Yes, it's data attributes is attributes, but what make a state of that object? So how can we change the state of the object?
When you assign value to it,
What's that?
when you assign a value to it,
Yeah, when you assign a value, yeah, some sort of combination of the value make a state. So you can think of state as a state in the real world, okay? So maybe I'm in a state of maybe body temperature, in a state of fever or not. It depends on my temperature value, okay? So the state there in the object is the same. A state, it depends on its value of the attributes. Okay, so if you change the value, then you change the state of that object. Okay, so if two identical object of the same type, okay, they have a same value. They have same value in their attributes. Can we say they're in the same state? Can we say that?
Yeah.
Yes? Yeah, probably. Can we say they are the same object? No, right. Because they have a state, yes, that values, The behavior is those method, and they also have the identity. Right? Even they are in the same state, same value, but still they are two separate objects. In your memory, they have two separate places, and the behavior, identity. Yeah. So they are two different things. And an object is an encapsulation dimension of the state, which is data value, and the behavior, operations. Thus, an object is in many ways similar to a module or abstract data type. You remember what is abstract data type? In the data structure class. What is that? And we will talk about that later. Yeah. A lot of many things about abstract data type. We will talk about that maybe next week. But it's an encapsulation. So we put them together as an object. Okay, here it is. Procedural language with OO languages. Okay, here are some example of the procedural languages. If you do not know, just remember the name. So next time when you are asked this question, you can name them. Okay. So operate on data a step at a time. Think about C. Okay. When you write a C, it's like lines in the main, and it's operate on the data a step at a time. And you can really define an object. You can encapsulate a function with a data. Right? You have to put data somewhere, and then you do the operation with a lot of functions, maybe sub-functions. A function is calling another function, sub-procedure. Okay. There are not a whole lot of object there. And it's actually because of the way when human first invented the computer. It's not like today's computer. It's a pretty straightforward thing. You give a series of input, it gives you a series of output, and internally it executes everything as a series. Okay, so that's a way it used to work. But with the faster computer developing, and we have different ways to do our programming, to design, to solve the problem. So that is OO. Okay. So yeah, a program written in this procedural language has two components: is data and code, just the data and code. Okay. Yeah. And in the memory, if you in the memory, it's a separation of code from data. If you are doing a C program. But what's similar is the code is also doing something to the data. That's the same in the OO programming. But what difference? Let's see what the difference is. An object-oriented language breaks the program into hundreds of tiny entities that have small bits of code and data fused tightly together. Okay, so it's separation, encapsulation. So basically, they're the same. They have a data code doing something on the data. Okay, but instead of they doing it together, they separate them as different hundreds of tiny entities and doing those. So why we're trying to separate them? It's because we want encapsulation. But why do we want this encapsulation? What does that benefit us? What's that? Yeah, there are a whole bunch of benefits. First, it's the security. Okay, so you cannot really access some of data you want to hide, right? The second, when we are separating them, we're actually using abstraction. We are abstract those data. We're trying to design these things more naturally, because object, how it works, object, and how do we solve the problem? We solve the problem when human beings, they solve the problem. They're trying to do abstraction, generalization, and trying to solve the classification, trying to solve a lot of problems. Like when we're trying to know the world, maybe you cannot remember when you are 2 or 3. Okay, you find, okay, there's the chairs. Okay, but chairs have different colors, right? And when you see another chair, you know, okay, that is a chair. So you're sort of doing those abstraction in your mind. Okay, so we borrow that kind of idea into this design. Then we form this kind of OO design. Yeah. All right, but basically they are the same. They are the same. The subroutines are convenience in a procedural language. The separateness of these entities is essential to OO programming. Yeah. The separation is what makes it special, what makes it stand out. Yeah, a new way to viewing the world. Okay, yeah, I guess an online idea of the OO technique are the same basic method humans use to solve the problem in the world. Like what I mentioned, yes, that's how we develop this OO ideas, because we want to make the program's life easier, right? That's why Java is called Java. It's a cup of coffee. We want to make things easier. Yeah, that's it. Computer professionals and children's. No, computer newbies and children's. Sorry, grabs the idea of the OOP easier than computer professionals. Yeah, sometimes it's like this, because you get into too much of some previous knowledge. It's hard to shift your mind to something else. However, if you are maybe not too good at something, it's easier for you to shift, right? Because I was trying to learn some painting, okay, when I was a kid. So when I shift from one style to another, it's easier for me than some other students. It's because those students, they are excellent at the previous painting style, but I'm not paying attention to the teacher at all. So I shift more quickly. But those students, they got too much knowledge on the previous style, so that makes it harder. Here it's the same. The professionals shift is difficult due to the preconceived notions. So preconceived notions, where the children don't. Right. That's something interesting. But this preconceived notions is really it's really have an impact on our life, right? Do you think so? Yeah, you know what is a preconceived notions? Yeah, it's really make you and yourself less adaptive. So when it's no offensive to senior people, but I think my dad is hard. It's hard to communicate with my dad because he has a lot of pre-experiences that he won't listen to me at all. Even no matter what is right or wrong, but I think that's because of preconceived notions. Yeah. I don't know if you have the same feeling or not, but when people are becoming like more senior, it's hard. It's very hard to change their mind. But for kids, it's different. For my daughter, it's easier to let her listen to me. Yeah, so easy. But when you shift from the procedure programming to OOP, yeah, it's the same. But the good thing now is a lot of people now start directly with the OOP instead of the procedure programming, right? So there's no such a problem here. All right, and some terms. We talk about object. What is object and class? So I mentioned that object is sort of more solid, but class is more abstract. So that's compared to object and class. But here we say a software entity that mirrors the real world in some way. So everything, basically everything in the OOP is an object. So when we're doing the modeling design, we see everything as object. And the class, yeah, you cannot have some portion of the code that is running without outside of an object, right? Can you think of that? No, that's OOP. And class is the template from which object are created, like a blueprint for object. And every object made from a class is the same as every other. Here the same is not saying that they are in the same state, just saying they are of the same type. Okay, just like here the same is like saying every people is the same, no matter you're female, male, man, woman, or yeah, something. But but still there are nothing like you're exactly the same, but of the same type. And instance, here is a little bit tricky. Instance and object, that's a little bit tricky. So instances are individual objects created by class. Every object is an instance of a class. So what's the difference between instance and object? Sounds like same, right? Yeah, to me it's the same. I always refer instance to object, but here it said every object is an instance of a class. Maybe it's broader, yeah, but yeah, most of the time we can say it's the same. Yeah. Instantiation is a created new object from a class, just like the keywords new. Okay, new, and you call some construction method, you got a new object. That's called instantiate. So instantiation, before the instantiation, this object is not in the memory. After the instantiation, there's a space in the memory for this object. So simple. And method should be easy, just those code. So what does method do? Here, if we use the OO idea, we call method behavior. Okay, so that's the behavior of that class, and or its instance. So it's described by the method. So method are like procedures. Method are procedures, not like. Just those are procedures. They execute step by step, right? Line by line. Okay, they do branching and looping. What is branching? What is looping? What is branching? Can you say louder?
The control doesn't have to come back
Doesn't have to come back.
to the same, like looping, you go through the same code again.
Yeah. Looping is for while. That's looping. Easy to understand. What is branching? So branching.
Branching is represented with the options. Options of execution.
Yes.
You either
Yes.
execute
Yes.
If else.
Yes.
A
Yes.
or line B based on the condition.
Correct. Just if you use the keyword to expand if else, that's a branch. That's one of the branching. Actually, branching is included in the looping, but so let's use the if else. What makes it branch? Okay. So maybe in the beginning of a method, it's going like this way, straight forward. At some point, it has a separation of the path. That is something like if else. Okay, so if true, then you go this way. Else, you go this way. So you have two ways to go. That is branch. Okay, so when you are doing the looping, you also have the branch, because at the end of every looping, you're gonna judge the condition of that looping. If the looping condition meet, then you maybe skip out of the loop. If condition is met, still met, you continue the loop. But if the condition is not met, you jump out of the loop, right? So that's branching. So every time when you execute that method, it's not necessary they're going to the same path, right? Because the value is different. So when you are judging those conditions, it's become different. So you have different paths. That's branching. So there is actually a way in the if you're familiar with the computer architecture, sometimes they do branch prediction. So they do branch prediction to improve the performance of your computer. Because at some point, this computer is not like doing one statement and another statement. Actually, when you are doing this one statement, it's already start maybe the fetching and data something of the next statement. So, but if you have branch, that becomes a problem. If you have branch, you have to decide which way to go. So you cannot prefetch those instructions, load those values to your register, to your CPU register. So we do branch prediction in the hardware. Okay, but here no, we're not talking about that part. Just we have a branch and looping in the procedure, in the behavior. Okay, so this behavior, this method, they take arguments. So arguments, it's like when you call a method, you give some value to call it, right? Okay, arguments. And they have local variables. What's the difference between local variable and the members and the attributes of the class?
Local variables only exist within that method.
Yeah. Yes. Local variable only exists within that method. Once you're out of this group, right, you have no access to those variables unless you do some hack. Yeah. But generally, you have no access to it. So local variables. Yeah, the word local pretty clearly explain this. Yeah, and it has return values. The values could be a value, could be an integer, something like that, and it could be objects. Some program language return the address, the reference, which is the memory address, to some certain object. But some program languages, they just return the whole object, and it also depends on the way you implement that. Yeah. So that's called method of a class. I think so far so good, right? Nothing too hard. So what makes it different Basically, they're the same, but here, still, some difference here. Okay. They may only access data of the class for which they are defined. So an instance data can only be accessed through its class method. Okay, so but that's in, so this description is in the object-oriented. But what about in the procedure programming? So the method can actually, their procedures, okay, procedures can actually access the data. Not because it don't have a, it doesn't have the abstract, it doesn't have the concept of the class object. So yeah, so it can access the data, not like globally sometimes. Yeah. And the class method completely encapsulates the data of the object of the class for which they are defined. Yeah. Yeah, if you want to access the data, you talk to the class. That's the ideal situation. Well, even in some programming language, even you are accessing the public data, private. Even you are accessing the public data by using the object dot something dot attributes. Actually, internally, it's still implemented as some sort of a get and set method there. Okay. And how the, so we have divided the procedures into different entities, but how can they communicate with each other? So that's through the message. Okay. So a message is a request to a specific instance called the receiver to invoke a specific method along with the name of the method and additional information such as the arguments. So they can be passed as a part of the message. Okay, so we all have this experience when we are trying to call, we're trying to use another object from a certain object. Okay, like you're using the teacher object is trying to access the classroom object, something like that. So when we're doing this, most of the time, basically it's using the message to send around, to call another message, to call another method in another class. And method has to be public, of course, and then you can call the method with a selector, which is like object dot something. With a selector, you can access that method, that procedure in your memory, and then with the message, you pass some data to another method. Then another method will run. Okay, so it can pass as a message as well. So we use message. And sometimes it's not like internally, it's within the computer with a message. If you think about web application, web service, has anyone do any web service in your previous work company? Yeah. So when you're doing web service, it's basically an object is here locally. Another object or method is on the computer, on the web, or on the cloud, something like that, web service. So when you are trying to use your object, trying to talk with the object on the other computer, it's talking through the internet. And then what your object do is it encapsulates this message into like XML form. Yeah, XML form. It includes the identity, the selector of the other object, which can be maybe the IP address where the object is, okay, and maybe the object's name and the method name, what do I want to call, and then it serializes the arguments. It can be a integer, something like that. Put that information into an XML, and then send that XML. Use that XML to access another object on the remote computer. So in that case, that XML file is a message you want to send, and use that message to call the other object, to call the method of the other object, communicate. So it's about separation. After separation, we still want them to work together, collaboration. That's through message. Okay. Yeah. When the object receives a message, think about a computer on a remote computer. Okay, I receive a message, so it invokes a method for the selector. This can change the object instance variables, which changes its state. Okay, this can, but it's not necessarily when I receive a message I will change the value. Okay, it depends on what kind of message I'm receiving. Okay, so it may change the value. That's option 1, and option 2 is sending another object back as a direct response, like the message is requesting for something, for some resource. I'm requesting for maybe the local weather. Okay, I'm returning that to you, but I can do that without change my variable, right? And 3, do something in the real world of the computer, such as display information, print a message, and read a block of data from a file. Okay. Yeah. So much of the code consists of passing message, pass around the message. Okay. And when we receive a message, when object receives a message, it can do this 3, one of the 3, and it can do any combination of the 3. Okay. Yeah, before we talk about abstraction. Okay. So as a summary of the procedure and object-oriented, 2 different type of programming. Okay. So it's like for us, for a human being, for a designer, programmer, it's different ideas. Okay, but at the end, in the end, when the computer execute everything, actually it's still similar for the computer, right? Because at the lower level, computer at the end still is doing the instructions, right? Instructions one by one. It's just different way is how can we design these instructions is different, but for the execution it's the same. Okay, for the computer still doing the same thing. If you like when we're trying to finish a task, like doing the print. Okay, if we are using the object-oriented programming, we need to first instantiate an object from the class. Then from the object, we call something to print a hello world on the screen. Okay. And for the procedure, maybe you do not need to define this object, instantiate object. No, you don't have to do that. You just directly call that method. If it's already compiled, you call that method, then you print something there. Okay. However, the computer, the instructions get by the computer, basically they are similar. That's the way we design is different, but the thing finally we send to the computer still the same. Okay. Yeah. So it's it's make the designer's job easier. So maybe after the object-oriented programming, okay, maybe someday there can be some natural language programming when artificial intelligence has been highly developed. Okay, so like I just tell the computer, okay, I print something. Okay, that's pretty easy. Okay, so I just tell the computer, I need I'm gonna build a calculator which can do a plus, minus, or give those what's called requirements. Okay, and computer understand my requirements and do the programming for us. Yeah, someday, yeah, it may happen. Okay, but not recently, but someday it will happen. But still, at the end, computer get the same thing. When you are trying to execute the code, it's still like those instructions. Okay, but for now, let's stick to the OO programming. Okay, so the way that make it easy is because it's more close to our learning process of the world. Okay, so our problem-solving process. It uses like abstraction, classification, generalization, and aggregation. Yeah. If you think a step more, it's going to be natural language programming someday. Easier. Just become easier and easier to communicate. Okay, but here, abstraction. What is abstraction? So it's a problem-solving tool that allows one to think of the problem at a higher level without worrying about the details. Okay. And abstraction refers to organizing information based on these three mechanisms: classification, generalization, and aggregation. Let's see what are each of them. What is each of them? Okay, so the classification. All right. In the classification, you forms new object by suppressing the details of individual instance and emphasizing properties of the whole. So new object types are formed by collecting the instance. So it's sort of like membership. So describe instance of relationship. So this may be a little bit confusing, okay, but as long as we see this example, it makes things clear. Okay, so this is a classification. Classification would allow one to collect the instance, like Jane, Bob, Sue, into a new higher order type called secretary. Okay, maybe we have 2-3 departments. Maybe one department has 3 secretary: Jane, Bob, Sue. Okay, and then we find something in common. We ignore the difference between Jane, Bob, Sue. Okay, maybe Jane is 25, Bob is 30, Sue is 20, something like that. They're different, but we ignore that. We find something common. Okay, they are our employee, they are our secretary of that department. So then we can classify them as a group, like secretary. Okay, so if we want to classify like all the persons here, how can you do that?
Students.
Yeah, student and teacher. Although I'm the only one member in that class. Okay, is there anywhere else?
Humans.
Yeah,
Maybe
yeah, well,
by
humans.
age.
Yeah, right.
Maybe like age or names.
Yeah. Age, yeah, maybe some age range, something like that. Or gender, okay. Good person, bad person, right? Yeah, okay. Okay, so that's how we do the classification. We try to find something in common between all this object. So then we can do this classification. And then we have an abstraction. of a class. Here is a secretary, or humans, student, teachers. Okay, so that's how we do classification. Let's go back here to the definition. So membership, instance of student. Okay, you are instance of a student. You are instance of student. So membership, yeah. And one important thing is ignore the details, and then you will find something common. Yeah, so that's called classification. Another thing is called generalization. Let's look at definition. So it merge existing types to form new types. Merge types. It's not merge objects. It's a merge of type, okay, to form a new type. So individual differences between subtypes are ignored, and common traits are emphasized. So generalization is like something like union. Put two different subtypes together. The same, still we ignore the difference, okay, and focus on the common things. But it's not from merge object, okay, like collecting object. It's putting this form a new from two types, two or more types to form a new type. Okay. So it is a relationship. Is a relationship. Maybe it's confusing, but example will save us. Okay, here. Following the previous example, so existing employee types secretary and teacher can be generalized to form the new type employee. Okay, maybe you generate, you classify Sue, the three name as a secretary, and then you find some other people collecting other object as a teacher. Then from this two type, secretary and teacher, it's not two objects, okay, two types. You generalize them to form a new type. What's in common? Secretary and teacher, okay, they are all employee, right? But they do different things in the school. But what common is they are all employees. So you merge them, have a higher level abstraction, employee, okay? So that's second, which is called generalization. All right. Still remember what is the third one?
Aggregation.
Yeah, aggregation. No, aggregation. Okay, I will still have a aggregation. Aggregation forms an object as a relationship among other objects. Is it sort of hard to understand? But let's see. Continue reading. It suppresses the details of the component and emphasizes the details of the relationship as a whole. It's not like emphasize on the common, emphasize on something in common, emphasize the same type. It's emphasize the relationship as a whole. It's sort of different from the previous two. Okay. So it's at the end you will see it's actually is a part of. Okay, I forgot something here. Here generalization. Here we say that it's is a relationship. Like a secretary is an employee, teacher is an employee, and this classification is instance of. Okay, like Jane is an instance of secretary. All right, and then we reach the third one, aggregation. is part of. Is part of. Okay. Let's see the example. Is part of. So consider the object type: stove, refrigerator, sink, cabinet. So, okay, something like that. Yeah, we find all those things have something not in common, but the relationship. They are all in the kitchen, right? So a kitchen object can be abstracted from the given objects. So the individual objects, like the stove, are the components of the aggregate. So, okay, so when we use another keyword is a refrigerator is a part of the kitchen. Sink is a part of kitchen. Stove is a part of kitchen. Okay. So that's define that relationship. Okay. So those three. We use these three tools to understand the world, the real world around us when we are pretty young, even now, right? When you're in some new environment, we still doing these three things internally. Okay. Maybe you're not. You didn't realize, but we do that internally. Okay, so here we're doing this in the design so that we can model the real world in the computer system. Yeah, so an instance of a component is said to be an attribute of an instance of the aggregate. So it could be the kitchen object has an attribute called stove, right? It's if you think about, let's think about Java, right? You can have those attributes like integer, yeah, but attributes are not limited to those basic data types. Like attribute can be can have a reference to another object. That's aggregation. Once you have a kitchen object, it has several members, and stove maybe one of them. So it's to be an attribute of. So stove is actually an attribute of the kitchen. Okay, so that's this sort of relation. Yeah, basic ways we have of structuring the information when they are repeatedly applied to the object. Hierarchies of new objects are formed. Yeah, that's how we learn our world. Okay, some more terms. So we were talking about information hiding, encapsulation. Okay, here's some formal definition of it. So information hiding suggests the decomposing system into components, like separate into entities. Decompose system into components that hide or encapsulate design decisions about abstractions. That's called hiding, right? So when you are separating the system into different entities, that's what we talk in the beginning of the class. We talk about procedural programming. Okay, difference is we separate the procedures into different entities, and how we separate them is by this abstraction, okay, by what I just talked, three ways of abstraction. Okay, data abstraction refers to defining data types in terms of operations that apply to object of the type, which constrain that the values of such object can be modified and observed only by the use of the operation. Yeah, still It can only be accessed by the operation in that object, within that object. And it's a way of abstraction. Yeah. And data abstraction is thinking in terms of what you can do to a collection of data independently of how you do it. Okay, so that's a thing we need to talk. All right. So why do we say you can do to a collection of data? What does that mean? What is a collection of data?
Data of similar type.
Just give a You can give a real world. Can you give a real world example of what you can do to a collection of something else? If you want to say data, I'll give you an example first.
Be like a list of names.
Yeah, it could be a list of names, but what can you do to a list of names?
You can modify the list of names.
Yeah, modify is one of the methods. Okay, so as maybe professor, okay, you have the operation over maybe if we think a student is a data type, which is abstraction. Yeah, it's a class and it's also a data type. Okay, so what I can do, what the professor can do to the student, is defined in the system. First is grade. Okay, giving grade. Okay, we can fail the student. We can give A. Right, that's what we can do to a collection of data. A collection means a student, a collection of student, collection of the same type. Okay. But what the professor can do to the maybe president of KSU, okay, you cannot give grade to him, right? But you can maybe submit evaluation, send out emails. Yeah, I cannot think of what else I can do to president. Yeah, maybe just send emails or talk to her. Yeah, but yeah, I cannot fail her. So that's what I can do to a collection of data. Okay, so what is an abstract data type? It's a collection of data structured in a particular fashion together with a set of operation and then manipulate that data. We will talk about ADT in the next week. But it's abstract data type. Okay, and inheritance, polymorphism, dynamic binding. Okay, polymorphism is something really confusing, but let's talk about inheritance. That's easy, right? Inheritance, this word explains what it does. Right? What?
Relation.
Yeah. What's that? Sorry, I didn't hear.
Relation.
Yeah. So the principle of it is it's actually reuse some of the maybe code from your parent class. Okay. For the subclass. The more formal way is this principle of receiving the properties or characteristics from an ancestor, and is used to define new data type as extension or restrictions of existing types. When we first learned object-oriented, I was told that inheritance is a way to reuse the code. Reuse the code. Okay. But I think more importantly, it's still the idea of the designing. When you are trying to define the relationship between this subclass and its ancestor, the code reusing is actually not helping you a lot. Because code reusing, what's the difference between it and the copy and paste? Right? Copy and paste is a code reusing, right? Do you think so? Yeah. So the more important thing is about the relations. You define the relations, and the relation is more nature to our understanding of the world. Okay, like the kitchen. Okay, kitchen, stove, and the stove maybe it's a subclass of a more general type of stove. Like a microwave stove is a subtype of a stove, something like that. Okay, and so why do we need inheritance there? Why do we want something to be a subclass of an ancestor? Polymorphism is one of the benefit. Okay. So, and the dynamic binding. Okay, polymorphism. Polymorphism. Program entities should be permitted to refer to object of more than one class, and operations should be permitted to have different realizations in different classes. Okay. So here, like, still the professor and student class. Okay, professor and student class. Okay. When we're doing the inheritance, we have a student class. Maybe student class can be an ancestor, and it has different subclasses. One is first year student. Okay, one is maybe second year student, and or different. Okay, student with 3.0 GPA higher, student with 3.0 GPA lower. Maybe you have those two subclasses. Okay. So maybe that's not a good example.
You're like an undergrad and graduate student?
Yeah. Okay. That's cool. Undergraduate and graduate student. Yeah. Okay. So we have undergraduate class and graduate class. They are inherited from a data type called student. Okay. So when we're doing the polymorphism, that means maybe when we design these things, design the system, first we do not realize there should be undergraduate and graduate. I'm just defining this professor, giving grade to student. Okay. Now I'm adding two different data types. One is undergraduate, one is graduate. If we're not using the inheritance, okay, so what I need to do is I need to re-implement this giving grade method to graduate and undergraduate. Okay, but if we're using this inheritance and polymorphism, that means something I do to the student is also something I can do to the subclass of the student. Okay, so when I'm doing something like in the code, maybe I am just executing a statement like putting grade, and then I give an argument of the type student. But what can be passed in the argument? It can be undergraduate, graduate student. Okay, so when you define, when you instantiate a new object of undergraduate, you can send that instantiate to the giving grade method. Okay, so does the graduate student. When you instantiate a student from graduate class, okay, you can pass that argument to the same method. That's how we call it polymorphism. So it looks like you are doing this operation to undergraduate, but also you can do that to graduate, because
But the implementation is a little bit different, right? Details of that implementation. Even though the methods have the same name, but the actual implementation,
Yeah.
the way you give grades to the undergraduate student may not necessarily be the way you give grades to the graduate student.
yeah, actually what I think is yeah, when you're calling that method, the implementation is the same, but there's a thing called like override. When you inheritance from your ancestor, maybe undergraduate and graduate, they have different ways of giving grade. Okay, different ways. So when you are doing that, you implement different types of giving grade method. You override it from the ancestor, so that how makes it different. But when we are calling that method, we ignore that difference because we know that we can do this to student and undergraduate and graduate. They are all student, so they should have some, either it's overridden or it's directly inherited from its ancestor, but it has something like that there, so that I can do this. So I ignore that difference. Yeah. To refer to an object more than one class, like we refer to an object of more than one class. More than one means undergraduate and graduate. We can use that. We can use the same reference. Okay, it's 7:47. All right. Yeah, that's it for today, and let's continue next week. Okay. I need to fix this next time. All right. Thank you very much for your time today.